Good morning, student. This is Utkarsh sir once again back with the problem which may seems to be a bit horrible, and that is why it is called capacitor monster maze. In itself, it is a monster maze which is actually not a monster or anything like that stuff. It is a simple problem of just 5 seconds. Now, first let me tell you the problem, what the problem is, then we will come on some more details. The problem is, all the batteries are of 10 volts, are connected in this circuit. You can see, I have mentioned the polarity of the battery, plus and minus 10 volt, plus and minus 10 volt, and so on. All the capacitors which are connected in the circuit, I hope you all are familiar with the capacitors. Capacitors are energy storing device, or I would say electrical energy storing device. All the capacitors are of 6 microfarad. 6 microfarad. Now, in this particular capacitor C, you have to find out the charge stored. In this particular capacitor C, you have to find out the charge stored. Now, in this capacitor which is underlined, you have to find out the charge stored. Its value is 6 microfarad. All the capacitors in the circuit are of 6 microfarad and all the batteries are of 10 volt. Now, the question seems to be a bit horrible and bit complex, but this can only be solved with the mental calculation of within 5 seconds. In order to begin like such problems, we need to know the concept of node voltage method, which is a best concept in our entire circuit theory. And talking about this particular problem, this is taken exclusively from the Walker. This is one of the world's best book, prescribed by many IITians and many authors, as I have said earlier also in my videos. This is one of the world's best problem of circuit. If you want to get skilled in solving a complex circuit problems, this is one of your choice. You can have this in your copy. So, now this problem is really simple. We need to find out the charge stored. Now, going to the basic definition of capacitor, we can say capacitor C is equals to Q upon V. This is the basic formula of capacitor. This is the basic formula of capacitor. This is the basic formula from which all other formulas are derived. Now, in order to find out Q, we can have a formula Q is equals to CV, where C is that particular capacitor, C is that particular capacitor, and V is a potential difference across that particular capacitor in which we are interested to find out the charge. Once again, Q is the charge stored in this particular capacitor, C is the value of this capacitor, and V is the potential difference of that particular capacitor in which we are interested to find out the charge. So, if howsoever we have to find out the potential difference only, because the value of C is already known to us. Now, the value of C is already known to us. We can assume the polarity of voltages like this, and potential difference across the capacitor is V. We have assumed that potential difference is of V and the polarity of charges are like such which I have shown in the figure. Now, the only game is now to find out the V, and we have solved the problem. Now, how to find out the V is the best concept of node voltage method. Now, we have to look, see, this problem will be very much difficult for you if you don't go from the basics. Don't write the equations and all. Just stick with this formula. You will land up with your answer. Now, we have seen that we have to find out the voltage. Now, let us assign this point at 0 potential. This point at 0 potential. Now, this has become a 0 potential. Then this line, in this line, there is no capacitor is connected. So, this entire line will be at 0 potential according to node voltage method. node voltage method will land up with a 0 volt here because there is no capacitor connected in this line. Now 0 volt is across, we have got here. Now the best way to solve this problem, you move in such a way that you don't have to encounter any capacitor. So only then we can write the voltages. So now you have two choices. You are here with the 0 volt. If you go this way, our capacitor is there. If you go this way, capacitor is there. But if you go this way, capacitor is not there, you will get a battery. You will get a battery of 10 volts. You will get a battery of 10 volts. So 0 volt here, it will be also 0 volt because no capacitor is connected. This will be also a 0 volt because no capacitor is connected. Now this point is at 0 volt. This point is at 0 volt. Now we are going from negative to positive, so there will be a voltage gain of 10 volts. So here it is 0. Going from negative to positive, it will be 10 volts here. Now we have landed up here with a voltage of 10 volt. Now if you have to see the path in which no capacitor is connected, you will try to go in this. Obviously you have two paths. One to go like this, and another one to go like this. Now this entire line till here, starting from here till here, it is at 10 volt. It is at 10 volt. Why? Because in this line there is no capacitor connected. There is no capacitor connected. If there is no capacitor connected, the entire line will land up this 10 volt voltage. Now this is 10 volt. Here it will also come 10 volt. Now you cannot say here it will be 10 volt because our capacitor is connected here. You cannot say that this point will also be at 10 volt. No idea, you will get wrong results. So it is 10 volt. Now again, if you see this line again, no capacitor is connected. Again no capacitor is connected, then again this 10 volt will rise up here. Now here this will be 10 volts. Here it will be 10 volt. Now in this entire line, there is no capacitor connected. So this entire line will be at 10 volts. This entire line is at 10 volts. This entire line is at 10 volt. Now this is 10 volt. See, now you have to come to this capacitor now. Ultimate aim is to reach this capacitor. Ultimate aim is to reach this capacitor. So this 10 volt is here 10 volt. Now again there is no capacitor connected, so it will be again 10 volt. So coming through this line, you will land up with the 10 volt here. Now this point is at 10 volt. This point is at 10 volt. Again moving from here to here, this will be 10 volt because no capacitor is connected. Again from this line, this will be 10 volt because no capacitor is connected. And again in this line there is no capacitor is connected, so this is 10 volt. My dear friends, the game is over. Now this plate is at 10 volt. We have to find the potential of this plate. Then only we can find out the potential difference. Mind you, this V is not potential, this is potential difference. So this plate is having a potential of 10 volt. Now if you find out the potential of this plate, you can find out the potential difference. This plate is ultimately at 10 volt. Now this is your 0 volt. This is your 0 volt. So it will also be the 0 volt. And rising from this line to this line, it will be at 0 volt. The game is over. It is at 10 volt here. It is at 0 volt here. Now the difference will be 10 minus 0. Which is at higher potential? This is at higher potential. So we have already assumed the right polarity of the voltage. It is at higher potential. Why? Because it is here 10 volt. This plate is at 0 volt. Now it is at higher potential. It is at lower potential. So plus sign here, minus sign here. So this will be the polarity of voltage here. And what is the potential difference? 10 minus 0. Because this plate of the capacitor is at 10 volt. This is at 0 volt. Now this 10 minus 0 will be potential difference. So again with this formula we can find out charge stored. So Q is equals to capacitor. The value of a capacitor in which we are desire to find out the charge is C, is 6 microfarad. 6 microfarad into 10 minus 0 will be 10 volts. So this is 10 microcoulomb. This will comes out to be in a microcoulomb. Why? Because we have taken the charge in capacitance in a microfarad. So the charge will be 60 microfarad, and here is the solution of this question. So see, if you go on writing the equations, you will be in some other word and you will confusing yourself only, which is the unknown, which are the unknowns, and what we have to find out. So follow these simple steps, follow the node voltage method. It is a much easier way. Now this video is taking time because I have to explain you the things. If you would have given me this problem, I would have solved it within 5 seconds and so on. So this is the basically reason where the node voltage has an exceptional beauty. Exceptional beauty. I can show you the book from which this question is taken. This is the book which I prefer, and this is one of the most my favorite. This is Resnick Halliday Walker. This is 8th edition, Fundamentals of Physics, and this is one of the world's best book. And I usually take problems from this book only because if you're preparing for physics Olympiad at a national level, so this book is, I think, a must-have book for all the students. And this question is exclusively taken from this book only. You can check out the page number. I will tell you the page number in the comment box. And this problem is such a beautiful application of node voltage method. So for more videos, you can stay tuned with us, and we will be back some more with the complex problems. And please like our video, subscribe, and please visit to our page and come and join with us. Join our institution. We'll solve some more complex problems like this within just 5 seconds. Okay. Wish you a great health. Thank you.